Good morning, students. Up to now, we have studied the force acting on an electric conductor. Okay, in that part, we have studied that if we place an electric conductor in an magnetic field, at that time, due to the presence of magnetic field, if we place an electric conductor, at that time, force will act on that conductor. Okay, and that force is in a perpendicular direction to the magnetic field. Okay, that part we already studied in the force acting on an electric conductor. Okay, so the next part we have to see that is the Fleming's left hand rule. Okay, so there we have studied if you place electric conductor in magnetic field, there are the CA1 diagram. Okay, in that it considers a horseshoe magnet. In between the two poles of a magnet, we place one electric conductor that is the wire. Okay, and we know in between two poles of a magnet, north to south, there is magnetic field is always present. Okay, so we place that electric wire in between this north and south pole. Okay, means in magnetic field of that magnet. Okay, so as we turn on the electric switch, at that time, as current passes through that wire, it bends. Okay, means what? It bends means somewhat force act on that wire, due to that it bends. Okay, automatically the wire will not bend. If we not pass a current, at that time the wire will remain same. Okay, constant. But as we turn on electric switch, at that time what happen? That wire get bends. Okay, so what happened actually there? Due to that force, wire is bent. So what happened? First of all, magnetic field is there. Then we place electric conductor. So magnetic field is a one thing. We place conductor and electric current pass through it. Means electric current is a second thing. Okay. Due to that current, what happened? It bends. And third thing, as we pass electric current, force will act that wire. Okay. So force is the third thing. Okay, so here relation between third thing is there. First of all, magnetic field. Due to magnetic field, as we pass electric current, means electric current is the one thing that we have to consider. And third is, due to that what happen? Force will act on that conductor. Force is the third thing. Okay, so here what happen? These three things are there. We have to find, we have to give relation between these three things. Okay, what? The magnetic field, the electric current, and the force. Okay, so there are something relation between these three things. That relation is given by is Fleming's left hand rule. Okay, what? Magnetic field, electric current direction, and force. These three things relation is defined by the Fleming's left hand rule. Okay, so in Fleming's left hand rule, Fleming tells us that we have to stretch three fingers of our middle hand. Okay, first of all, the thumb, this is index finger, and this is the middle finger. We have to stretch these three fingers such a way that three are mutually perpendicular to each other. Okay, what? Finger, index finger, and middle finger. Thumb, index finger, and middle finger, such a way that both three are mutually perpendicular. Look at these two are mutually perpendicular to each other. These two are again mutually perpendicular to each other, and these two again mutually perpendicular to each other. Okay, so such a way that we have to stretch thumb, index finger, and middle fingers. Both three are mutually perpendicular to each other. Okay, and if you place these fingers such a way that our index finger, this index finger is in the direction of magnetic field. Okay, index finger is in the direction of magnetic field, and middle finger is in the direction of electric current. Then the remaining finger, thumb, that denote us the force acting on an electric conductor. When we place electric conductor in magnetic field, due to that magnetic field, what happen? The force will act on that conductor. That force will be in the direction of the thumb, when our index finger in the direction of magnetic field and our middle finger in the direction of the current. Okay, so this relation is given by this Fleming's left hand rule. Okay, here we have to only remember some things which are the what force, magnetic field and current. The relation between force, magnetic field and current is given by the Fleming's left hand rule. Okay, and that rule tells us that if we stretch three fingers of left hand, that is the thumb, index finger and middle finger, such a way that both the three are mutually perpendicular to each other, then if we place our index finger in the direction of magnetic field, middle finger in the direction of electric current, then our thumb will be denotes the direction of a force which act on an electric conductor when we place it in magnetic field and current pass through it. Okay, so statement of this Fleming's rule also we have to remember. It is related to the left hand. In last time we have studied the right hand rule that tells us how can we find out the direction of magnetic field. Okay, here what happened? Here we have to find out the force direction. Okay, force will be act on electric conductor when we place it in the direction of a magnetic field. Okay, so such a way that you have to remember here these diagrams. Okay, suppose here this is the our here this is the force direction, then this is the magnetic field direction and this is the current direction. Both the three are mutually perpendicular to each other. Okay, that we have to remember again. Okay, both the three are mutually perpendicular to each other. But upon here, both the three things are mutually perpendicular to each other, that we have to remember. Current direction, magnetic field direction, that two are mutually perpendicular to each other. Magnetic field direction, force direction, that are the again perpendicular to each other, and the force and current direction that are also perpendicular to each other. So both the three things are mutually perpendicular to each other, which is given by the Fleming's left hand rule. And statement of rule is that if we stretch our left hand such a way that our index finger in the direction of magnetic field, our middle finger in the direction of electric current, then our thumb will denote us this direction of a force which is act on an electric conductor. Okay, that is the statement of Fleming's left hand rule. You have to remember statement of the Fleming's left hand rule that may be asked in an examination, and also the diagram also we have to remember. We have to only show both the three things are mutually perpendicular to each other. So your force in the direction of thumb, magnetic field in the direction of index finger and current in the direction of middle finger. That things you have to remember, and also you have to remember statement of this law. Okay.